radioactive decay and nuclear radiation, this is all due to unstable nuclei. So, got lots of nuclei here. Some of them are going to be stable, some are going to be unstable. And what they do is that unstable, they randomly decay. They either give off particles, I'm going to talk about these types of particles in a minute, or they give off electromagnetic radiation. So they've got to be unstable and it is random. And the more unstable they are, the more quickly they decay. And we can measure this activity, this decay, in becquerels, which is BQ. So the greater the number of becquerels, the more decay that's occurring. So what are these types of radiation that can occur? This one I've drawn here is called alpha, and what alpha radiation is 2 protons and 2 neutrons. The 2 protons are positively charged, the 2 neutrons don't have a charge, so the overall charge is +2. So we can represent alpha as alpha +2. This type of radiation here, represented with one circle, is beta. And what beta is one high-speed electron. Electrons are negatively charged, so beta radiation has -1. So we can represent beta as beta -1. It's really important to note that alpha is not an atom because it has no electrons. And this last one, the radiation, is gamma. Gamma is no particle at all, it's just electromagnetic radiation. It has no mass and it has no charge. So gamma is just a Y. There's also another type of radiation, which is neutron radiation, which is just a neutron particle which has a mass of 1 and has no charge. So they're the types of radiation. They are all ionizing. And what ionizing means is that they can cause an object to be charged. For example, if we bombard DNA with radiation, alpha is going to be the most ionizing because it's got the biggest charge. Alpha, most ionizing. Beta is still going to be fairly ionizing because it's still got quite a big charge. Gamma is the lowest, is the least ionizing because it's not got a charge. And what will happen to that DNA if we're bombarding it with alpha, beta or gamma is that DNA will become charged itself. So that's what ionizing means. Causes something to become charged. So you would think that alpha is the most dangerous because it's the most ionizing, because it gives it the most charge. But that's not always the case because alpha is the least penetrating. Alpha cannot even go through paper or skin. So the alpha can't get inside your body because it can't even penetrate skin. It can actually only go a few centimeters, let's say 5 centimeters in air. But beta is more penetrating. Beta can go about 20 centimeters in air. It can penetrate the paper and skin, but it's stopped by thin metals such as aluminium or steel. So beta, about 10 centimeters to 20 centimeters. And gamma is the most penetrating. Gamma can penetrate paper and skin. It can penetrate through thin metals, and it can even penetrate a little bit through thick concrete, thick lead. So you have to make it really thick. The thicker it is, the less it penetrates. So thick lead, concrete, that's what gamma cannot penetrate, and even then we might still get a little bit penetrating through. So gamma is the most penetrating. Gamma, most penetrating. So gamma is the most penetrating, alpha is the least penetrating. So from far away, gamma is the most dangerous, even though it's the least ionizing. If we've got the radioactive source inside you, alpha is the most dangerous. Even though it's the least penetrating, it's the most ionizing. It's the most ionizing, causes changes to your DNA, causes mutations, increases your risk of cancer.